Welcome, experts and engineering enthusiasts. Today we are surveying a piece of junk. The discovered target is a camera, outdoor security. The current condition is extremely bad. Layers of mud and rust have completely covered the original surface, evidence of being abandoned for many years. This device operates based on photoelectric principles, capturing light and converting it into digital signals. I immediately collect it and transport it back to the laboratory. A comprehensive evaluation process is needed. 4 journeys traveling across the countryside. The device is ready on our technical operating table. 5 visual analysis shows a cast aluminum alloy shell. The heatsink design helps maintain the circuit board temperature. 6. The bracket part is completely calcified and rusted. Oxidation has eaten deep into the screw threads. I proceed to disassemble the U-shaped base. Next, the outer protective shell needs to be removed. I use this screwdriver for the front cover. Amazing! The inner chamber is filled with clumps of dirt and rocks. The IR infrared LED cluster seems to have been buried. I carefully scrape off the fossilized mud layer. A bamboo root steel brush is the ideal tool right now. It breaks the physical bonds of the hardened mud. I brush hard along the heat-sink grooves of the aluminum body. The original metal layer gradually appears faintly. Use a hammer to tap lightly to create mechanical vibrations, breaking off the super tightly adhering rust patches. A box cutter is used to shave off buildup in narrow gaps. This stage requires absolute patience. 4. Proceed to pry open the cover, revealing the infrared LED circuit board. These diodes emit high-frequency rays. It provides visibility through the night for the sensor. I use this screwdriver to take it out. Pull out the entire central processing module from the cylindrical housing. The internal electronic components are also thick with dirt. The system includes a CCTV lens, optical image sensor, and printed circuit board containing the signal microprocessor. A high-precision screwdriver is used here. Remove the tiny screws to release the electrical circuit. Successfully separated the circuit board from the mount. Wiring system. The signal cables have completely rotted due to humidity. Components are placed neatly in an aluminum tray, ready for the intensive microchip cleaning process. I use a toothbrush for mechanical scrubbing, removing dirt from surface mount SMDs and ICs. Soft brush, finished cleaning the gaps of the lens assembly. This fixed aperture helps with optimal light capture. 4. This rough cleaning helps prevent short circuits. Prepare the surface before using chemical solutions. Today I continue cleaning the lens's copper inductor, removing the green rust corroding the surface. Apply solution. Specialized cleaning on the lens thread ring. Brush off dirt from the specification symbols. Finished, removing the CCTV lens metal label from the front protector, revealing the inner layer optical lens system. Use a cotton swab with isopropyl alcohol to wipe the lens edge. Ensure no dirt residue remains on the lens. Use a heat gun to completely dry the circuit board, preventing mold and short circuits. Separate the lens assembly from the sensor mount. The CMOS image sensor appears intact. Gently wipe the IR cut filter surface of the sensor. Avoid scratching the optical anti-glare coating. 1. Remove the screws securing the lens focus ring. Separate the individual lens elements inside the tube. 4. Carefully remove a broken lens piece. Unfortunately, the inner filter has been damaged. 5. Pick out the broken glass pieces from the chamber. We will find a suitable replacement part later. 6. 4. Put the intact lenses into the cleaning solution. Use a cotton swab to lightly polish the curved surface. Spray alcohol to clean fine dust stuck deep inside. The solution evaporates quickly, keeping the glass dry. 1. Wipe dry with a microfiber cloth to prevent glass scratches. The lenses have restored maximum transparency. 1. Proceed to remove the screws holding the main PCB. Detach the image signal processing circuit part. 2. Use a brush to apply specialized circuit board cleaner. The solution cleans off rust around the IC pins 3, 2, 1. Clean the area around the central processing microchip. Ensure circuit traces are not broken or cracked. Clean the surface mount component pins on the board. The circuit board is as shiny as if it just left the factory. Moving on to the cleaning of mechanical components. Soak the entire shell in a soapy water bath. Use a large brush to scrub off the mud aggressively. The fossilized dirt layer begins to dissolve completely. Cleaning the infrared LED circuit board in a water solution. Scrubbing off the stains around the lamp pins. 4. Using tweezers to pick up screws from the pickling bath. The acid has dissolved all the adhering calcification. Placing the small screw components on a towel to dry. They are ready for the reassembly stage. Pouring specialized cleaning powder and water onto the aluminum body. The chemical reaction helps strip away the old paint layer, thoroughly scrubbing the narrow gaps inside the device body, removing long-term accumulated dirt from the inside. 1. Using a scraper to clean off the tightly adhering aluminum oxide. The white powdery aluminum rust layer flakes off. 2. Putting the aluminum housing into the wire wheel grinder, polishing the metal surface to reach its original brightness. 3. 4. Proceeding with primer and a blue electrostatic powder coating, protecting the aluminum shell from the oxidation process. The base mount part is also carefully treated, then matching the paint color with the main body. Using a multimeter to check circuit continuity, measuring resistance levels and confirming the circuit board status. 4. Final cleaning of the CMOS optical sensor surface, ensuring there is no microdust before assembly. 4. Firmly securing the lens mount with screws. This step determines the stability of the focal axis. 5. Preparing a brand new protective glass faceplate. The rubber gasket will help the device reach waterproof standard. 6. Reinstalling the lenses into the lens chamber, precisely aligning the optical axis of the system. 4. Placing the aperture controlling copper inductor in the right spot. The protective metal rim is locked tight. 5. Cleaning the outer surface of the lens with solvent, tightening the lens module into the mount on the circuit board. Screwing the insulating copper pillars around the sensor. This is the solid support for the infrared circuit board. 1. Securing the infrared LED board with tiny screws. The core recording module has been fully restored. 2. Threading the signal cable through the waterproof rubber slot, using pliers to tighten the cable retainer at the end of the device. 3. 1. Connecting the power supply and video transmission jacks, pushing the entire component core deep into the aluminum shell. 2. Placing the rubber gasket and tempered glass on the front, tightening the red cover to seal the machine compartment. 3. 2. Assembling the sun shield to prevent glare and splashes. The sliding design allows for easy overhang adjustment. 3. Assembling the ball joints of the wall mount base. Tightening the bolts to fix the camera's viewing angle. A brand new look with a perfect shiny paint coat. Now it's time to put the device to a practical test. 1. Taking the device to the installation spot on the porch. Proceeding to secure the junction box with wall screws. 2. Connecting the DC power and BNC coaxial cables. Mounting the camera on the wall and aligning the viewing angle. 3. Firmly securing the swivel joint with a screwdriver. Activating the system. The infrared LED cluster glows brightly. 4. Light sensor is working well. Activating night mode. Going back inside to check the signal from the DVR. Turning on the central monitor connected to the recorder. The video signal is transmitted stably and instantly. The displayed image is sharp with clear details. The project to restore the discarded camera has been a complete success.